tackled was it's often difficult to relate the infrared data to the real world. To look at a screen and look back up at the real world and see where it coordinates. The way we decided to tackle this is by projecting this data onto the real world, so the human brain can easily correlate the data. We also decided that we were going to want a user interface for this system, so we added in a visual camera as well. This allows us not only to add in a laser pointer to go through our user interface, but also to correctly calibrate our system so that we're projecting right on top of what we want. Some of the goals that we decided to do, because of the fact that we needed to limit the scope of this project, we found that the camera was very good at seeing studs through walls on cold days. So we decided that we were going to implement a stud finder algorithm. Another thing that we saw that we could do was create a thermographer, something that can project the temperature of a specific point. Also, we decided to create a function that let us save the images coming in from both of our cameras and also the images that we're projecting at any point in time. Another thing that we're doing is just with homography, it's making sure that things are projected directly on the surface that we're projecting on. So some big changes that we went through from last semester to this semester. Last semester, we had this implemented on a laptop, a Windows 7 laptop. This semester, we wanted to make it portable. So we moved over to a Panda board that's running Ubuntu. One of the issues there was that this has a quarter of the memory and about half the processing power of the laptop that we were previously on. So we had to focus on optimizing our code to correct for this. Another change we made was we were getting our data in through a TV tuner card, or infrared data. That was able to change when we were able to get a leopard board, leopard imaging. Then we were able to get the data in through a crossover cable. Any questions?
This is senior design 2.
This is senior design 2.
What were the performance benchmarks that you had problems with achieving in 1 that you addressed in 2?
So the big thing was lining it up. So if you see in the picture in the bottom right there, it was getting the projection to actually line up with the hand. Before, we weren't able to do that. So something we were able to change was to implement homography, planar homography, which is a set of functions that allows you to map two separate images together, and fixing our devices to allow us to do that so that we can project within an inch of where things is once our device is calibrated.
Did you have to write these algorithms, or what?
Oh, well, so we had to write the implementation of these algorithms.
So what did DRS provide you in terms of the starting point?
They provided us with the DRS Tamarisk camera, which is the thermal camera, and then through their contacts with leopard imaging, they were able to provide us with a leopard board, which takes in data, is connected to the camera, and processes the camera and turns it into the data coming in into frames and sends it via a crossover cable, which is like an Ethernet cable, but it allows you to connect two computers without using a switch in between.
Did you have a DRS mentor, and if so, how often did you meet with that person?
Yes, we did. We have Dr. Skidmore, who's here with us. And we were able to meet with him fairly regularly, at least once or twice a month.
As often as he wanted to, or as often as you wanted?
I don't see that there was a difference.
Are they happy with the design?
Are you happy with our design?
I'm happy with the design. I think you should all come